Hello and welcome to the first lecture video for this course. We're going to go over sections 1.1 and 1.2, systems of linear equations and row echelon form. Now feel free at any time in this video to pause it if you need to jot down some notes. You can always fast forward if I'm going over something a little too slow or if you've seen it before. You can also go back and replay anything that you need to hear more than once. Also, if there's anything you don't understand or if I make a mistake, feel free to email me, or if you want me to go over something in more detail, you can email me and I'll try to correct it or make another video with whatever you need explained in more detail in another video. Okay, let's start off with linear equations. So what is a linear equation? So a linear equation is an equation that looks like this, where we have a sub 1 times x sub 1 plus a sub 2 times x sub 2 all the way to a sub n to x sub n, where n is greater than or equal to 1. And this is going to be equal to b, where all of these coefficients in front of the x's are either real numbers or complex numbers. It depends on what field you're working with. Usually we will work with the real numbers. We have an equal sign, and then we have this x sub 1, x sub 2. These are variables, and you'll also see them called unknowns in your textbook. So we have real numbers and variables, and notice that the powers on each one of these variables is 1. Now if you have something, like a squared here and a 3 here and a negative 1 here, this is not a linear equation. The powers on your unknowns have to be 1. Now you've probably seen linear equations before. Usually we have something like 3x plus 2y is 5, or 3x plus 2y minus z is 6. These are linear equations. We've just, instead of naming them x1, x2, and x3, we do x, y, and z. We label them like this because, especially if you have a lot of unknowns, it's easier. You don't have to come up with a bunch of different letters to represent your variables. Okay. What is a system of linear equations? So a system is just two or more linear equations. So a quick example. So 5x sub 1 plus 2x sub 2 minus 3x sub 3 is 8. That is a linear equation, where here the n is 3. And then we could add 2x sub 1 minus 7x sub 2 plus 0x sub 3 is 9. This would be a system because we have two or more linear equations. So this would be two linear equations with 3 unknowns. Now we're going to see very complicated linear equations and systems. So let's generalize this idea. A linear system of m equations and n unknowns. So we're going to have m equations, and you see this number, so we have this a sub 1, 1. Now we saw before that it was a sub 1, but now we have two numbers. This first number goes with the equation number. So this is the first equation. So all of these, for the first number has a 1 here, and this one also has a 1. You see 2, 2, 2, 2, 2, all the way to m, 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 so on. So we have m equations. And then our variables, x sub 1, x sub 2, and so on. You can see that this number corresponds to the variable. Okay, see that here? And you can see that this doesn't have a variable, so we don't put a number with that. So again, the second one, you can see you have a 1 here, that goes with x sub 1, and so on. Okay, so you might have, let's say, a system of 10 equations and 15 unknowns. You're going to have a lot of information, and we want a nice way to write all of this stuff. And we're going to also be solving equations, so we also need a nice way to solve them. And what we're going to do is we're going to use matrices. So how do we represent a linear system as a product of matrices? Well, notice how I labeled these. They kind of look like entries in a matrix. And that's exactly why I labeled them this way. So what I'm going to do is I'm going to take each one of these coefficients in front of these x's and I'm going to put them in a matrix. And I'm going to call that matrix A. So I have A11, A12, all the way to A1n, A21, A22, A2n, keep going. And this is going to be my matrix A. And then I'm going to multiply this matrix by the variables. So we had x sub 1, x sub 2, all the way to x sub n. And I'm going to call this matrix X. I'm going to put an equal sign, and then I'm going to make a matrix B, or I'm just going to put all of the B's that we saw. Let me just scroll up again so you can see it. So I'm taking all of these B's. Then you can see I have n x's. Okay, scroll back down. All right, and if you know anything about matrix multiplication, you can see that we take to multiply these two matrices, you take this row, multiply by this column, and you get this first entry here, which is exactly the first equation in your linear system. Then to get the second equation in the linear system, you take this row, multiply it with this column, and you get this, this number here. And we'll go back over matrix multiplication, but this is just a quick little review. Okay, so this is another way to represent a linear system. So let's look at a quick example. So let's say we have x plus y is 1 and x minus y is 0. So here my coefficient is 1. I have a coefficient 1, 1, and 1. I could notice that I didn't put x1 and x2. I just used x and y, but it's basically the same thing here. You go 1, 1, 1, negative 1. X, y is 1, 0. So you can represent this system like this. If you don't like this x and y, put x1 plus x2, x sub 1 minus x sub 2. All right, now this equation, this system is really easy to solve, right? Because you can see that x is equal to 1 minus y and x is equal to y. So for something simple like this, we can use things we learned in algebra to solve the system. But we're going to have some complicated systems, so we would like to solve systems using matrices because it'll be a lot easier. So before we do that, I want to talk about the 3 different situations that can occur when you solve a system. So solving a system means we're figuring out the variables that we need to plug into the equations, the linear equations, to make them true. So for example, this one here, you can see that x is equal to y. And from the top one, we get that 2x is equal to 1. So we get x is 1/2, y is 1/2. So this one has one solution. 1/2 plus 1/2 is 1. 1/2 minus 1/2 is 0. So this is our solution. 3 things can happen when you have a system. You can have one solution, infinitely many solutions, or no solution. So here we have one solution. An example of something that would have infinitely many solutions would look like this. X plus y is 1, 2x plus 2y is 2. Now you can see all I did was I took the first equation and I multiplied it by 2. So this is technically just x plus y is equal to 1, which if you solve for y, you get y is 1 minus x, which is the equation of a line, and all the points on the line are solutions to this equation. So this has infinitely many solutions. Okay. Another situation you can have is where you have just no solutions at all. So for example, x plus y is 1, x plus y is 2. This would have no solutions because you can see that, well, at one point, x and y, when you add them together, you get 1, but then also if you add them together, you get 2, and 1 is not equal to 2. So this has no solution. So think back to what you know about lines just in two-dimensional space. Visually, when you have two lines, they can either cross at one point, they can overlap on the same line, or they can be parallel lines, right? So you had, when they cross, that was one place where they crossed. When they overlap, then all the points that they cross is exactly the whole line. And also, if they're parallel lines, they don't cross at all. And that's exactly what's going to happen when you have n unknowns and m equations. So maybe we should write that. Let's see, I'm going to write it, let's just write it here. Erase all this. Okay. So for a linear system with m equations and n unknowns, there are 3 possibilities. For solutions. The first one Number 1, you have no solution. The second possibility is you have infinitely many solutions. And the third possibility is you have one solution. So if you can find 2 solutions to your system, then you automatically have infinitely many solutions. So you can find infinitely many more solutions, okay? So these are the 3 possibilities for any linear system. And, I also want to mention that if a linear system has no solution, then we call it an inconsistent system. You might see that in your textbook. And if we have infinitely many solutions or one solution, we call this a consistent system. I'm not going to quiz you on this, just for your knowledge. If you read that in your book, that's what inconsistent and consistent means.